Hi, I'm Mr. Matt, and today we're going to continue with AP Statistics Section 1.3, Topic 1.3, which is about the tabular representation and summary statistics for one categorical variable. So it's important to understand that today, all the variables that we talk about and all the ways that we explain that we can represent those variables, these only apply to categorical variables. If you recall, in topic 1.2, we learned that there are two major categories of variables. There's quantitative variables and there are categorical variables. So today we are just talking about categorical variables. All right, so the most common way that we will represent data about categorical variables is using something called a frequency table. So what is a frequency table? It is a table that shows the number of observational units in each category of a categorical variable. So let's go back to the data set that we were using in our topic 1.2 video, which is a sample of data from residents of Beijing, China, who are adults. And we have 7 different variables about these residents. We have their district, their age, their marital status, their height, their weight, their education, and postal code. And remember, of these, 4 of them, there's 7 variables here, 4 of them are categorical: district, marital status, education, and the postal code. So how would we make a frequency table for one of these categorical variables? Well, let's talk about the categorical variable of marital status. So that's what we're gonna focus on right now. We're gonna focus on this marital status variable here. And remember, the first thing that we're going to be doing is we want to talk about the distribution of this variable. If you recall, in topic 1.2, I emphasized that the definition of distribution is very important for you to kind of get a grasp of. A distribution of a variable is just all the different values that that variable can have and how often the variable takes each of those values. So in this variable, marital status, in our data set, there are only 4 different values that the variable could have: married, single, divorced, and widowed. And we can see that it's married happens 1, 2, 3, 4 times. Single happens 1, 2, 3, 4 times. Divorced happens 1 time. And then widowed happens 1 time. So that is the distribution of this variable: married 4, singled 4, divorced 1, and widowed 1. That's the distribution. And a frequency table is one way that we can show a distribution. So let's look at an example of a frequency table for marital status. So here it is, very simple. We just list out the different categories that this categorical variable could have, all the different values that this categorical variable can have, and how often it takes those values. So we've got married, single, divorced, widowed, 4, 4, 1, 1. There are 4 married individuals or observational units. There are 4 single observational units. There is 1 divorced observational unit, and there is 1 widowed observational unit. So that's the whole concept of frequency table. Very easy. All right, you just count how many are in each category of that variable. Let's do it for a different variable. Let's look at education. Let's see all the different values that the education variable can have. Well, there's bachelor, master, high school, bachelor, we already have that one, master, bachelor, junior college, bachelor, master, bachelor. Okay, so once again, we have 4 different values of this variable: bachelor, master, high school, and junior college. And we can count how many observational units are in each category. Bachelor has 1, 2, 3, 4, 5. So down here in our frequency table, we're going to write, oh my gosh, my writing on this board is so bad. All right, bachelor's has 5, okay? Then we can count how many masters. We got 1, 2, 3 masters. So we can see here that we got 3 masters. And then how many high schools do we have? Just 1. And so we got 1 high school. And then how many junior colleges? Also 1. So that is the distribution of our variable, and we can display that distribution using a frequency table like this one or like this one. Okay, so that's it. That's what a frequency table is. Let's go on. There's only one other kind of frequency table that we're going to talk about in this section, and that is a relative frequency table. Now, in a frequency table, it displays the count or the number of observational units in each category. 4 married, 4 single, 1 divorced, 1 widowed. But for a relative frequency table, it tells us the proportion. So, of course, how do we find out what the proportion is? Well, we just find out what the number, the count is. Let's call that X. So we have X is the number in each category. And then we just divide that by the sample size. And in this case, our sample size is 10 because that's the total number of individuals or observational units. So we have 4 divided by 10. That gives us 0.4. That's the proportion. Or 4 divided by 10 again gives us 0.4. 1 divided by 10 gives us 0.1. 1 divided by 10 gives us 0.1 again. So this down here is an example of a relative frequency table. A relative frequency table because it tells us or shows us the proportion. Or it could be percentage. Either way is fine. So here I've done the same relative frequency table in 2 different styles. This one uses proportion, 0.4, 0.4, 0.1, 0.1. And this one uses percentage, 40%, 40%, 10%, 10%. Same idea. Okay. Note that ratios, 4 out of 10, proportions, 0.4, and percentages, all right, 40%, they all provide the same information. So it doesn't matter if you write it as a ratio, a proportion, or a percentage. But make sure you're clear. If you write 40, make sure you put a percent sign behind it. Don't just write 40, okay? Next, another thing to note is that the frequencies in a frequency table should always add up or sum to the total number of observational units in the set or the sample size, n. So up here, when we have our frequency table, these numbers should always add up to the sample size. 4 plus 4 plus 1 plus 1 is 10, and we have 10 individuals or observational units in our sample here, so that's correct. Okay. Of course, if we're talking a relative frequency table, the relative frequencies should always sum to 1. Okay, so 0.4 plus 0.4 plus 0.1 plus 0.1 is 1, because you always have 100% of the individuals or the observational units. Okay, so that's really all of the information that's contained in topic 1.3. It's a little bit shorter, so let's just do a few practice problems real quick, and then we'll wrap up this video. So let's look at our AP practice here. It says a local community center surveyed 80 teenagers about their preferred weekend activity. The results are summarized in the frequency table below. So we have a table here, and then it says, based on this table, which of the following statements is true? A, the observational units are the 4 different activities. B, exactly 20% of the teenagers surveyed preferred volunteering. C, more teenagers preferred reading than sports. And D, The most common weekend activity among the observational units was sports. All right, so let's look here. The observational units are 4 different activities. That's not true. Remember, the observational units in a frequency table. This is a little bit tricky. When you're looking at a frequency table, you don't see the observational units. You only see the number of observational units in each category. So notice there's 28 observational units that like gaming. There's 22 that do sports. There's 14 that do reading, and there's 16. We don't see all those individuals or the observational units. We just see the number in each category. So the observational units are not the 4 different activities. That's not true. There's 80 observational units in this frequency table. Next, exactly 20% of the teenagers surveyed preferred volunteering. Well, volunteering, there's 16 of them. All right, so 16, if we want to figure out what percentage that is, we would just go, 16 divided by the total number, 80, and then we would multiply that by 100%, and that would give us the percentage. Well, 16 divided by 80 is 0.2. So this is actually going to be 20%. Oh, so it looks like this is the correct answer, B. But let's check the other ones real quickly. C, more teenagers preferred reading than sports. That's not true. Reading only had 14. Sports had 22. And D, the most common weekend activity was sports. That's not true because gaming had 28 and sports only had 22. So the answer is B here. Okay, let's look at the next problem, number 2. A software developer tracks the primary operating system used by 250 different clients, the observational units. The developer began creating a relative frequency table, but has not yet finished it. What is the correct relative frequency for the Mac OS category? Okay, well, that's not too difficult to figure out. We know, we had just stated above, that the relative frequencies must always sum to 1. Okay? So they must always sum to 1. But here, we don't know what this one is, but that's easy. We can figure it out because it's just going to end up being 1 minus the sum of all the other ones. So 0.5 plus 0.16 plus 0.04. Okay, so that's going to be 1 minus, and then if you add those together, it looks like it's going to be 0.7, right? 0.7. So 1 minus 0.7 is 0.3. So the answer should be A, 0.3. Okay, so that's how we do that problem. Next, let's look at number 3. An urban planner is studying the primary mode of transportation for employees at a large tech hub. There are 500 employees, observational units, included in this study. The following relative frequency table was generated. How many of the observational units primarily use a bicycle to get to work? All right, so this time they tell us that 12% or 0.12 proportion are going to be using a bicycle to get to work, and we know that there's 500 total. Now remember, the relative frequency is the number in that category divided by the total number. Okay, so that means that 0.12 has to equal the number in that category divided by the total number of individuals or observational units, which we know is 500. They told us that. So if we want to figure out how many of the observational units use a bicycle, we just need to solve for x in this problem. So it's just going to be x equals 0.12 times 500, which is 60. All right, so 60 is the answer to that problem. Okay, and then our last problem here. A researcher is analyzing the year in school for a sample of 400 college students. The researcher creates a relative frequency table to summarize the distribution. Which of the following must be true regarding the sum of the relative frequencies in this table? Well, the sum must equal the total number of observations. All right, well, the sum of the relative frequency won't equal the number of observations. The sum must equal 1. C, the sum depends on the number of categories. The sum must be equal to the frequency of the most common category. No, well, this is just basically testing us on what we learned above. Remember up here, we said that relative frequencies should always sum to 1. So that's the answer to this problem. The sum of the relative frequencies must equal 1. All right, so that is all for topic 1.3. I hope you'll join me next time when we start topic 1.4.